So my name is Godbehere. I'm the Technical Fellow for Smart Factories at the Advanced Manufacturing Research Centre. So we're going to spend the next maybe 15 minutes or so just giving you an overview of who we are, what we do, why we exist, a brief introduction to MQTT and Sparkplug for the uninitiated, and how it solves some of our connectivity challenges as a research organisation. And then I'm going to give you an overview of some of the work that we've done internally at the AMRC to hopefully try and accelerate the adoption of Sparkplug within the manufacturing sector. So the AMRC, we're a non-profit, partly government-backed research organisation based out of the University of Sheffield over in the UK. Our main aim really is to take low-level, unproven research, sometimes directly from the university, but not always, and develop it and de-risk it to a point where it is of sufficient maturity to be adopted by industry. Typically, not always, but typically, research tends to be relatively cheap to prove out in a lab environment. But it's expensive to develop and de-risk to the point where industry are prepared to adopt it. So historically, there's been a bit of a disconnect. Our job as the AMRC is to have 1 foot in industry, 1 foot in academia, and try and align the two. And we do that by making the mistakes for both academia and industry in a sterile but representative environment. So we've been around since about 2001. So we're about 20 years old now. And we consist of around 500 active research staff across different sectors. So areas like machining, composites, materials, structural testing, castings, and connectivity and the industrial Internet of Things. If you're ever in the UK, in our neck of the woods, please come and see us. We'll show you around. We're really proud of what we do. Jeff can attest we do pretty good pies, right? But as we've grown, and you can see an image of our facility in Sheffield in the top right there, we've had a number of kind of high-profile manufacturers move in next door to us. So you can see Boeing, McLaren, and Rolls-Royce have facilities nestled amongst the AMRC buildings in Sheffield. And those aren't research facilities, they are their production facilities. And they were chosen exclusively due to the location and the proximity to the AMRC's research. So we're extremely proud of them. Now, as a high-value manufacturing research centre, typically, the research we did was applicable to aerospace and defence. But over the years, as we've conducted more digital-facing research, it's also applicable to other sectors like rail, the medical industry, civil engineering, automotive as well. And although we aren't a production facility, our main export is intellectual property, we do share the same challenges around OT connectivity as the vast majority of manufacturers. We have a whole host of weird and wonderful machines within our facilities. Very rarely two are the same, and we use the data from those machines frequently for research purposes. So you may have seen this before. I've stolen it from your website. Sorry. But like most, as we grew as an organisation, so did our digital requirements. And coupled with the rapid acceleration of digital technology in the last kind of 10 years, we ended up with solutions that were kind of organic, lots of point-to-point connections. They didn't scale very well. It was very Frankenstein-like. A new technology would come along, we'd bolt it on, and again and again. And it simply wasn't fit for purpose. So not only from an operational perspective, but also as a research organisation that others look to for best practices, it simply wouldn't do. So we set out to standardise the way that we connect to our OT and IT equipment within the organisation. And doing that not only, again, from an operational perspective, but also so that we could document that journey and hopefully allow others to follow in our footsteps for things that went well, and to not make the same mistakes as we did for the things that didn't go so well, which there were many, just me. So we did quite a lot of intensive research, and we came across these 3 principles which resonated with us. So the first one is report by exception, and I'll dig into these in a few moments in a bit more detail. So the first one, report by exception. The second one, connect to infrastructure. And the third one, be edge-driven. And these really would form the cornerstones of our architecture that we would then go on to deploy. And it became apparent that if we adopted these principles, the architecture that resulted would be lightweight, scalable, and performant, and ultimately fit for purpose. So the first one, report by exception. So this is the concept of, rather than asking a device, a sensor, for its value, we allow it to tell us its value when that value changes. Now, there are obvious benefits in terms of kind of network bandwidth for this, especially if you've got devices out in the field where network bandwidth is at premium. But the one that resonates with me is the ability to have theoretically higher resolution data from your machines. So if you're polling a device, you have to decide on a polling frequency, right? And that is theoretically the highest resolution data you're going to get from that machine. If you have devices out in the field, maybe once a minute, once an hour, once a day, depending on your network bandwidth. If that value changes within that window, you're only ever going to get the latest value. With report by exception, you get every single value every time it changes, using only the amount of network bandwidth it requires to transmit that new value. So principle 1, report by exception. Principle 2 is connect to infrastructure. So the idea of having something like this, turning into something like this. The diagram on the right is simpler to maintain, easier to manage, easier to secure, and significantly easier to onboard new devices. So a good analogy to this is when you go to a website on your laptop, BBC website, CNN website, you don't plug into their servers every time. You connect to an infrastructure, you connect to the internet. And that's what we're trying to get to here. So principle 2, connect to infrastructure. And the third one, be edge-driven. So this is the report from report by exception. So benefits include improved security. So rather than having to open a port in the firewall to allow a request to come in to ask for a value, the edge device simply broadcasts the value when it changes. So client-initiated, edge-driven. And it's ideal for low-power devices. So if we go back to the diagram on the left, if one of those devices on the bottom row there on the diagram on the left had to respond to, let's say, 10, 100 things that cared about its value once a second, it's responding to the same question with the same answer 100 times a second, rather than doing its job, which is to monitor a process. With an edge-driven approach, the sensor, the device, monitors the process and informs the broker, the infrastructure, when that value changes once. So third principle, be edge-driven. So most of you will be familiar with what MQTT is, but effectively it's a protocol for IoT communication. Pub-sub, publish, subscribe based. So the general idea is you have an MQTT broker in the middle, or a set of MQTT brokers for redundancy. You have data producers on the left, which will publish a value to a topic, an area on that broker. And then things that care about values, subscribers on the right, will connect, register their interest in a topic, and receive the data when the subscribers send that data. So MQTT was originally developed in the 90s, and it was used in, is it Philips 66? Oh, yeah. More recently, industry has started to adopt it. And quoting Arlen earlier on in the presentation, it was designed to keep it simple, stupid. So very flexible, no payload definition, no topic definition. You can define that however you want based on your application. But as it started to be used as kind of a standard protocol within industry, different people used it differently. So the analogy I like to use is we have MQTT, we have a method to communicate. So we have a telephone, we can communicate. but I speak Mandarin and you speak French. We can physically hear each other, but we can't understand the words, the packets. So that's where Sparkplug comes into it. So I appreciate I'm preaching to the choir here a little bit. Most of you will be familiar with this, but if not, we can share the specification. If you Google MQTT Sparkplug, it'll be one of the first results. But ultimately, Sparkplug is an open source specification that lays down the rules for how to use MQTT within an industrial manufacturing environment. It defines a payload definition, so what the packet should look like. It defines a topic structure, so where those packets should be sent to, and it defines a state management model. So now, going back to the telephone analogy, we have the use of a telephone, we can physically communicate, but also we now both speak English. So as the AMRC looking to deploy a standardized architecture, having both of these documents, we have MQTT, and we have a theoretical way to deploy MQTT in an industrial environment with Sparkplug. Fantastic. Now what? Sparkplug does a really good job of defining what, but it doesn't necessarily say how, and that's by design. So at the AMRC, we implemented Sparkplug, and we documented that journey, and that turned into an open access framework, which we call Factory Plus. So this is a public web portal. You can visit the URL, you can scan the QR code. We welcome feedback. But it's an open access framework that defines how to practically establish a unified namespace using Sparkplug within a manufacturing environment. So yes, it covers what Sparkplug is, what MQTT is, how it's used, but it also covers things like network infrastructure, containerization, orchestration. How do we deploy those containers to the edge and centrally? How do we upgrade them? How do we fail over? How do we scale? It defines infrastructure as code best practices, so taking best practices from the IT domain and bringing them into the OT world. It defines data schemas, data models, protocols and encoding, which is the Sparkplug element, device management, edge connectivity, historians, long-term storage, sending and receiving commands with authorization and authentication through Sparkplug. And then recently, we've added a whole new section to outlining how we consume data ultimately collected by Factory Plus and Sparkplug, which we call the consumption framework. So the idea here is that Factory Plus is a start to finish manual, really, for deploying Sparkplug within an industrial environment. So I'm now going to hand over to my colleague, John Hall, who's going to show you how we're really practicing what we preach and how we've deployed Sparkplug via Factory Plus at the AMRC and what we use it for in a research setting. Over to you, John.
Hi all. So Alex has spoken about the reasoning behind the way that we've deployed Factory Plus, the building blocks that we've used. What I want to talk about is a little bit more focused on the actual deployment, how it is deployed across buildings, what we're using it for, and what I'm really excited about is some of the research that Factory Plus has enabled within the AMRC. So with that in mind, Factory Plus, sorry. So we started using Factory Plus as an operational tool based on a lot of the tools that we've been hearing about, talking about this week, Ignition, Sparkplug, Canary. All these things are implemented to help us to collect data, communicate with machines, share data across groups, across buildings, and it means that we now have more ways to access, more ways to use the data that we have already being reported by all of these machines. The first port of call for a lot of this, once we've connected a new machine, is to create a dashboard for it. So we can see we've got a few examples here of dashboards for 3D printers, furnaces, filament winders, all personalized to be displaying the data that is key to that machine, the data those operators want to see. And yeah, those are customized to be exactly what they need to be. So the deployment itself is, in summary, Factory Plus is deployed across 7 buildings on 4 sites across the UK, all over the AMRC in its various incarnations. And using Sparkplug means that when we want to connect a new device in one of these sites, it comes down to a simple checklist. Physically, where is the device? What information is it reporting? And essentially, what protocol is it talking? What translation is needed to be done? So that's also enabled us to connect a wide range of devices. As Alex said, we have a weird and wonderful array of things at the AMRC, and a large number of those are now connected to Factory Plus. On the extremes of that, we have a 60-year-old lathe in the bottom left corner of the screen there that obviously in its initial construction has no sensor capability built in. So that's fully retrofitted with vibration sensors, power consumption sensors, temperature sensors, all these things to enable us to gather data from that extreme legacy machine, package it into a Sparkplug payload and report it up to Factory Plus. On the other end of the scale, we have a KUKA Titan, which is the next picture to the right from the lathe, one of the largest payload robots commercially available, controlled by a Siemens 840D PLC. And using the same methods, we've been able to connect that very high-tech modern machine into our network and collect data from it. You may argue that's much better quality data, but that's not for me to comment on. So, and the other thing that we've got on the screen here is, just as I've been talking, on the right, we've just got an example of a visualization of the network using Shifter. So we can see birth messages popping in from all the devices that we've got active, and just at the end there, that's a sort of example of the standard traffic going across the network. So we've got payloads being reported on all these different topics, just pinging back and forth all day. It's quite hypnotic to look at. I just have it open on a second screen sometimes, just to relax me. So moving on from that into some case studies, and you'll have to excuse me for looking at notes because this isn't my work and I kind of want to do it justice. So the first thing I want to talk about is a project from our composites team that was looking at the adaptive control of a composite cure. And essentially what we have is an oven publishing its temperature data over the MQTT broker that's being subscribed to by a control application. Oh, sorry, I'm looking at the wrong screen. So that control application subscribes to the temperature data based on live temperature data, historical temperature data, and some information about the component that's being cured. It's able to extrapolate the cure maybe 10 minutes into the future and generate a oven power output that will maintain the cure temperature without overshooting, causing the problems that come with that. So that power output goes through what we call the command escalation protocol. That's something that we've generated within Factory Plus. As some of you might know, within Sparkplug, only the primary application can send commands. But in this case, the control application issues a command request to the primary app and says, I want to tell the oven to set its power output to 80%. The primary app can check the permissions of the control application. If everything checks out, that command is sent onto the oven. So we have remote control of the oven based on a much more intelligent control algorithm than the one that's inbuilt into the oven controller. And just to give you the headlines of the results of that work, we ended up with a 70% time saving and a 50% energy saving compared to a standard curing process, because we were able to cure at higher temperatures for a shorter time because of that live monitoring and the more active control of the oven. One of the things that I love about this project, it was actually proposed by the composites team. They came to us and said, we want to be able to do this. We want to be able to remote control one of our ovens. And because of Factory Plus, we were able to say, we already have the infrastructure to do that. We just need to connect the oven into it, and then all of this is possible. And it's a great feeling to be able to say that. Took a lot of work before that, but yeah, made things easier. So yeah, we've got a genuine pull from the research teams for this capability, for this level of connectivity that we've got. The next case study then, and this is where I really need my notes, is looking at using a neural network approach to more accurately predict the cutting cycle times for a robotic machining cell. This is something that is possible through simulation, But in general, what you see is an underestimation of the lead time because the simulation doesn't know the physical attributes, the limitations of the robot that you're using. So, as a lot of you will know, the starting point for any AI research is going to be acquiring large amounts of high quality data. You need that training set, you need a testing set, and you need to be sure that all of that is high quality. And using Sparkplug, we were able to generate that data, a structured data set from essentially automated trials. So with data having all of its context from the edge, we weren't having to worry about collecting the data, then contextualizing it, then storing it. That was all just being done on the network. So it almost became a set of lights-off trials. The robot was doing its thing, data was being collected, stored. When it came to analyze, that just had to be pulled down from the historian. And Tim, one of our AI guys, did whatever he does. And we were able to get some really good results out of that. But the takeaway for us from the in the connectivity team was that using IoT, we've created this environment where AI research can easily be carried out. And one of the interesting things is that all of the data from this persists in the historian. So in future projects that may be in a similar area, those physical trials may not even be necessary. It might be that we have the data, we already have a data set to start with, and that project can be done in half the time, potentially. So moving on to our last case study, we have a zero-knowledge digital twin application. The idea is that we have a consumption framework that sits on the network and provides contextualized data to the consumer of that data, to the person creating and observing a digital twin. So the supervisory digital twin requires no prior knowledge of the cell that it's a twin of, and 3D models and metadata, as well as how they should be used, are pulled dynamically from the network, and at the same time, live data is subscribed to from the cell. Those are brought together, so it means that you are visualizing that live data with context that has been pre-written, that has been provided by the consumption framework. So when you have a set of 6 numbers that are all your axis angles that have come from a robot, rather than looking at that as a set of 6 numbers, that has been visualized based on the consumption framework and using the CAD model of the robot shown as the actual position of the robot, as if you were looking at the actual cell itself. So the consumer of the data doesn't need prior knowledge of the system in order to see the information that they need. And that's the main takeaway from this one. So just as a final word on this then, Factory Plus is a pipeline that we've generated using, again, the tools that we've been talking about all week. And it's enabling us to exploit research data much more effectively, and it's enabling us to move into new research areas and enable a lot of that research that we couldn't do before. As Alex said, all of this information is available on the website. There's a QR code up there. It's also accessible through our badges, so if you find us, feel free to scan those, and our website is the Factory Plus website. But for now, thank you for listening.